Copernicus came about right when Ptolemaic astronomy was starting to get back to its old glory. The first European, the first astronomical treatise in Europe was by John of Holywood in 1233. It was a translation of an elementary Arabic treatise, only one chapter on the planets, not particularly advanced. For the next 2 centuries, there was little other than commentaries on this book and unsuccessful attempts at replacing it. We start to see technically proficient astronomy, according to Coode, only really about 2 decades before Copernicus' birth. They had started to really understand Ptolemy and start to apply it with as much skill as the ancients and as the Arabs had done. So Copernicus is kind of at the heyday of European Ptolemaic astronomy. Copernicus' motivations. As we said, he hated equivalence. He thought there were these perversions of nature. He believed that he was very, he had a lot of Neoplatonist influences. So he believed that mathematical simplicity was paramount, which is why he hated equivalence. He loved circles and epicycles. He hated equivalence. He thought mathematical simplicity was paramount. He also had some very interesting Neoplatonist things going on with the sun. For some reason, the sun had become very tied into this Neoplatonist ideal, and it was kind of the life-giving force of the universe. And so he thought that the correct place for the sun was at the center of the universe. So these are essentially his motivations. He wants to get back to the simplicity of the epicycle and the deferent, and he wants to be able to put the sun in its rightful place at the center of the universe. And this is Copernicus' motivations. The actual book, De Revolutionibus Orbium Celestium, was a very technical treatise, very much in the Ptolemaic tradition. Except for the fact that it put the sun at the center of the universe, it's very conservative. Arguably more conservative than most Ptolemaic astronomy going on, because it got rid of equivalence. But obviously, it had one crucial difference. It put the sun at the center of the universe. And this had some nice properties. It gets rid of major epicycles. It doesn't get rid of epicycles. There are lots of epicycles in the system. But it gets rid of the ones necessary to explain retrograde motion. It explains the problem of the inferior planets. Because, right, if Mercury and Venus are closer to the sun than they are to us, we will be looking at them toward the sun, in a sense. Because they will always be identities of us. So, if we've got the sun at the center of the universe, and Mercury, Venus, Earth, from a given position on Earth, Mercury and Venus have to be somewhere in here. So they'll either be like right next to the sun in our line of sight, or they'll be a little bit off, but not that much. Or they'll be back here and they'll again be close. So it explains the problems of the inferior planets. And this was great. I mean, that's a legitimate advantage of his system. But it still used minor epicycles, it still used eccentrics, and it utilized over 30 spheres. It's not really that much better than the Ptolemaic system, and its predictions are no better, except for this one qualitative prediction of the inferior planets. It's not really that different from the Ptolemaic system. But these advantages were enough, and there were enough other Neoplatonists running around, that this worked. People were interested. A lot of people didn't buy it, but there were definitely people who were interested. But it's not the end-all be-all. There are lots of problems. This causes huge problems in physics. Because now, why do things fall to the center of the Earth? Why would things fall here instead of here? It doesn't make any sense. You're getting rid of what we know about physics in order to create a system that's not any better than the system we already have in astronomy. It creates great problems with religion. Because this Aristotelian idea had been entirely co-opted by Christianity. There's a long and complicated history. Some people hated Aristotle, but I'm not going to really go into it because I don't have time. But there was definitely a large strain in which Aristotle was combined with Christianity. Dante, in the Inferno, he writes, the person starts at the crust of the spherical Earth, goes down through the 9 spheres of hell, then back up through the 9 spheres of heaven. And so this idea that the most corrupt place in the universe is at the center of the Earth, and the most perfect place is at the edge of the universe, and that there's this parallelism between the 9 spheres of hell and the 9 spheres of heaven, which relies on this two-sphere universe. And this explains man's unique place in the cosmos, because man is right at the border between the 9 spheres of hell and the 9 spheres of heaven. He's in a place where change is possible, but things are not really corrupted in the same way that they are beneath the earth. So there's a lot of stuff going on. There's a lot of very Aristotelian, very Earth at the center of the universe stuff going on. So this is a problem for religion. It's problems for physics. It still doesn't make sense in the same way it didn't make sense when Aristarchus said it. Because, again, you throw a ball up, it comes back down. Again, we're standing here, and we don't feel like we're moving. We don't have trouble standing up. It's very unintuitive, has problems with physics, has problems with religion, has a couple nice mathematical properties, but mostly is no better. There are plenty of good reasons to not accept the system. But there's enough mathematical niceties that some people bought it anyway. One of these people, excuse me, before I say that, there was a guy named Tycho Brahe, and he was crucial. He got very, very precise data for the time. And more importantly, got enough data that Europe could stop relying on the ancient data tables, which were often wrong. A difficulty in creating an accurate system is that any system you create is going to be wrong if you compare it to incorrect data. So this was helpful to get actually accurate and more precise data. He also introduced a compromise system, with the Earth at the center of the universe, the sun and moon rotating around the Earth, with the other 5 planets rotating around the sun. This is beautiful because it is geometrically equivalent to Copernicus' system. This took me a while to see. Some of you seem to see it already, but I will explain it to those of you who don't, because it didn't make sense to me for a long time. So you've got the Copernican system. This is terrible circles. The Earth at the center. You can think of the lines of sight between these. So things are moving in this direction. You can think of the lines of sight from these things like this. Let's say this is the Earth, Mercury, and the Sun. You can think of it as going like this. And these are both moving in this direction. And if Mercury is moving faster than the Earth, this is going to essentially fold in on itself. Can you visualize that? So this is moving faster than this. And so this is going to end up over here while Earth is still over here. It's going to fold in on itself. Alternatively, you've got the sun rotating around the Earth and Mercury rotating around the sun. And instead of this, you've got, so the sun is rotating around the Earth, and Mercury is going around, sorry, I need to get my bearings on this. If Mercury is moving around the sun slower than the sun is going around the Earth, then again, you get the sun over here and Mercury over here, and it folds in on itself again. And you do this for all the planets, and they're geometrically equivalent. So Copernicus' system is Tycho Brahe's system, except that Tycho Brahe's system isn't crazy like Copernicus' is, because it leaves the Earth at the center of the universe, doesn't screw with religion, doesn't screw with physics. This is a beautiful compromise. And this brought a lot of people over. They didn't want to accept Copernicus' system because it was nuts, but they would accept Tycho Brahe's system because it's geometrically equivalent but not crazy. But there were certain people who still liked the sun-centered thing because maybe they thought the sun was the provider for the universe or something. They got some Neoplatonist stuff going on. Or whatever else. For some reason they liked Copernicus' system better than the less crazy Tycho Brahe system. One of these guys was Kepler. Kepler was a radical. Kepler thought that Copernicus had not gone nearly far enough. He thought he should have blown Ptolemy out of the water and started over. And that's what Kepler did instead. And it worked. Kepler came up with his 2 laws. The 2 laws say that instead of, we don't need these circles, instead, let me make sure I get these right. Planets move in elliptical paths, with the sun at one of the, what's the word I'm looking for? Foci. Yeah, one of the foci. So, and that's the first law. The second law, the orbital speed varies so that a line joining the planet to the sun sweeps through equal area in an equal amount of time. This is kind of the opposite of an eggplant. So you've got a planet and a line between the planet